We're live. Oh, wait, let me put Scott. Scott is here. There we go. Scott is here. And we're going to try to answer. He's frozen. Oh, there he is. He's moving. We'll try to answer all your questions. Some of the questions I collected from the last week. So we're going to iterate between the questions from last week that we couldn't answer and questions today. Hey, Scott, there is a question for you later on.
Hello.
Okay, so first one, and this only Scott can answer or nobody. I don't know, Scott. Do you have home lab?
I do have a home lab. I actually have 9 Raspberry Pis and 3 servers running in my home lab. So I would say the minimum HA home lab is going to be 3 Raspberry Pis, and you can do a lot with that. I get 3 nodes, just, and have a good time. If it's 4 Kubernetes, Raspberry Pis are great. If you want to be running more powerful stuff, get some Intel NUCs or things of that sort. But you can really push those devices and the mini PCs a long way these days. So definitely an easy and achievable thing. Doesn't need to be expensive.
So here's a question for you. If you're making HA, do you put those Raspberry Pis in different rooms of your house to simulate different zones or something like that? No?
They sit on top of one another with currently in my environment, because I was too cheap to buy actual cases. I have a friend that has a 3D printer who printed out like a stack for me to put in the Raspberry Pis in. And I have an old desk fan that's sitting in front of them to cool them down, and everything works, because I also like playing around with them. But, I do not have availability zones. That is true.
Because what might happen is that you have a cup of whiskey and you spill it and it destroys your whole cluster. If you separate it into different rooms, there we go. It's safe. It's HA.
They do actually sit just under my 400 bottles of single malt at home. So, the whiskey protects it.
Okay, next one from Gulam. Now this is live. How to learn things more efficiently, like dummy environment creations and stuff, like always in a hurry, not able to pick the tone of work. It's not just about technical. The only thing I can say that I'm completely chaotic, so I don't know how I do learn things. What I do know is that I'm trying to figure out what are the things that I can learn that are somehow connected with what I do for money, right? So to have a, hey, I need to do X here, over there, and among 57 different things I would like to learn, this one might actually somehow be applicable to that.
Yeah, and I would say also, just use the quick starts of different tools. If you're looking at something, start with the quick start. Don't start with the Kubernetes the hard way. Don't start with the getting deep down. Do the quick start, do the happy path, get your basic knowledge in. From there, then go in deep dive. But people make the mistake, I think, too often of deep diving from day 0. And I think that's wrong.
Yeah, because if you go deep dive from day 0, what happens is that you still don't know whether you should use it or no.
Exactly.
Right? Like you're wasting too much time. You should be, in my head, you should have some idea at least whether this is useful for you or no within an hour.
Right.
Exactly. That's the quick start thing.
Exactly. Start with the quick start. See, okay, this basically has value. I could see this possibly. Destroy that, and now go and look into the real environments, look at real setups, and start going down that approach. Definitely don't stick with the quick start, but start there, see that it's valid, validate your general understanding, make sure it makes sense, and then go in deep dive into things.
Okay, the next one. This is from before, from last week, and I think that this is where both me and Scott are going to agree, at least on the first question. Are either of you using rendered manifest pattern for Kubernetes? Is that a thumbs up from you? Yes, exactly. Absolutely. You should do that.
Yes.
And which tool I don't think it matters. I mean, it matters kind of like we have our preferences, right? Scott might like something, I might like something else.
Yeah.
But that to me, that's a question of syntax, right? Which
Right.
syntax you like more than others.
Exactly. And tools to implement this, though, like it could be taken in two ways, right? If you mean the templating tools, I'm a masochist and I like Carvel YTT personally. I know that Victor likes Q and other, or you're not in Q anymore, right? You moved to something else.
No, I'm in KCL now.
You're in KCL now. Right. So again, there is that language. And then there's the fact of like tools that actually do this. There were tools, Jenkins, X did this, whatever. My answer is you don't need a tool that does this, that's its job. You have templating engines that template and just run that in your CI. That is the job of running in CI. It does not need a dedicated tool that does that for you. Just run whatever it is, Q, KCL, YTT, Helm, template, customize in your CI, push that back up to Git as the last stage.
Okay, now we have a one that we might actually disagree, me and Scott. So is OpenTelemetry still way to go to dev starting from scratch? So let me give you a very quick pitch. I think that whether we use OpenTelemetry or no matters mostly or almost exclusively for instrumenting our own code. And I couldn't care less when there is a third-party exporter running in my cluster, whether it's using OpenTelemetry or no. I don't care. It's putting data somewhere, somehow.
Yeah.
I'm more interested kind of like whether we should use OpenTelemetry when instrumenting code, because that's the investment, right? It's not kubectl apply. It's I need to write code to add code to my application so that it can generate metrics or traces or whatever.
So my general approach on this is that OpenTelemetry is definitely the way to go for tracing. It is not the way to go for metrics. And the reason is because metrics should be Prometheus.
Yes.
That's just pure. You can't fight the industry. The amount of tools and ecosystem built around the Prometheus ecosystem is huge. The amount of tools around tracing was not that large and was so all over the place, unlike metrics, which reached that standardization through Prometheus standards, which is why Prometheus is what you should use for metrics, because you always know it's there. OpenTelemetry is great for tracing, and logs, please just log to std out and follow best practices and let something pick that up. I don't care what picks it up, if it's FluentD or FluentBit or Loki or Promptail or OpenTelemetry collectors. Doesn't matter.
Yeah.
Throw it to std out. That's all you should care about as an application.
Exactly. Okay, so we're on the same page. This is boring, Scott. Okay, we need to find something more controversial. Okay, this I haven't tried. I don't know if you tried to expose pods IP on the same worker network. What tools do you use for that?
So to expose to have the pod IP be on the same network as nodes, that's very typical in like EKS with VPC CNI, where it creates it on the same one unless you do secondary networks, and there's ways of doing it in other networks, but traditionally in the cloud, you can get that in any of the major clouds. I do not believe that is a good idea. I believe that is a horrifyingly bad idea because it enforces bad practices. Pods should not be anything you ever target. You should be targeting services, and therefore having your pod routable makes no sense. What should be routable is services or ingresses to your applications. There's a reason that Azure, for example, have been recommending everyone to move to the encapsulated networking topologies where you don't have routable pods, and based on Cilium and a very good data plane there. When it comes to on-premise, if this is related to on-prem, I will say on-prem routable pods is a nightmare that the devil created with himself. If you are running on VMware and have the whole VMware stack, use Antrio with NSX, and it's great. If you aren't, good options are Calico does have a good option with route reflectors, and you can do BGP there. You can do BGP with Antria. I believe that Cilium, I'm not a Cilium guy myself as much in self-managed. So I don't know if they have that capability, but almost all CNIs do. So not really an issue. I would never recommend it on the same network, though. And the reason for that is that you typically are also going to want different firewall rules, different things like that. If things are being exposed outside, that's typically more standard in traditional enterprises. And their segmentation really matters. So have it on separate networks. And that's where Multis can come in to give you secondary networks and do multiple VLANs and have weird topologies of multi-network pods and things like that. Don't do it unless you absolutely have to, because it is a nightmare to manage.
There you go. Okay, the next one. Q or JSONet or KCL for real-life enterprise use case. Let me start and then you trash my opinion over there. JSONet is a nightmare. I never could... actually, maybe probably it's good. It's just that my brain could never process it. I don't know. There's something wrong with me, not necessarily with JSONet.
No, there's something wrong with JSONet.
Okay, I'm being nice, man. Come on. Q is cool, but it has some quirks and some. My experience with Q was, in 80-20 rule, kind of like I could do immediately. I was productive. Immediately, I could start writing it. And then I could get stuck on some silly thing that is silly and easy anywhere else for days or hours, right? So it's kind of love and hate relationship. And KCL is like Q, but easy, without silliness, just the good parts in a way. So my vote goes for KCL. And I will guess Scott's vote goes for none.
My vote goes for YTT or KCL. YTT would be way above, but if it has to be from this list, it would be KCL. I am not a fan of JSONet. KSONet was an attempt to try and make that better in the Kubernetes world from the guys at FDO. That died very quickly and was proven to not work well. Q, I think, is too much a programming language, but not a programming language, but is a programming language, but isn't a programming language, that it just didn't make sense to me. KCL is a bit more sane in that place. I think we have to realize that not everyone that writes YAML manifests or Kubernetes manifests knows Go. Not everyone that does is a very good developer. And that shouldn't be an entrance barrier. And I believe with Q that it is. YTT or KCL, I think, are easier for the non-developer to wrap their head around. And I know Victor will say that everyone is a developer. No, that we do.
Yeah, but okay, we agree on that one. Okay, it's still boring. Come on, man. Okay, this one is for you. I'll let you answer first because I know that you're using Flux much more than me. How to automate installation of CRDs with Flux?
Yeah, so the answer is there's many ways of doing it. I always recommend, if there might, typically for third-party applications like Istio, like many others, there is always a Helm chart of the CRDs, and then there's the Helm chart of the application itself. That's become a relatively big standard amongst a bunch of the open source tools because of Helm's lack of good support around CRDs. So for that, I always recommend having just separate Helm releases, one for CRDs and one for the thing itself. I do not believe in the whole let's create one huge application in Argo CD style thing with all of our Helm charts and then deal with sync waves and all of that. Have separate applications for every single component, and at some point reconciliation will happen because I have a bunch of applications that have been created and everything is fine because each one will fail but will finally succeed. The second you put things together, just watch Victor's video on the benefits of sync waves or the magnificent, horrifying element of them, that, you know, everything goes bad when you put too much together. So separate it from the application, have it in separate resources of Flux, be it a Helm release or a customization.
The only thing I will add is that I feel that it is a sad situation that CRDs, and I'm now referring to both tools, both Argo CD and Flux, that CRDs are simply not first-class citizens, kind of like. I mean, I understand what you're saying. I agree. You need to separate them, or you suffer a nightmare if you don't. But I will also say that it's a sad that we still have to do that.
I completely agree. I also understand why it's so challenging, right? We understand why it's challenging because I'm trying to validate an API that doesn't exist, right? And that it becomes, so I agree with you. I wish it were better. I think that Flux handles this a bit more seamlessly than Argo does. And the reason is because, again, I will contradict what I said before about how we should be doing stuff with, raw manifest, templating out YAML and doing that. If you are using a Helm release and not just the customization, so you're actually having Flux do the Helm install, it actually runs Helm install. So whatever is tested upstream for how Helm does things, that is how the application was built, like Istio, and that is going to work with Flux. Argo CD does Helm template, and therefore it does not always work the same.
Yeah, but now I'm going to be defender of Argo CD. Actually, in that specific case, the fact that it's doing Helm template allows Argo CD to evaluate all the manifests and order them. So it would actually install CRD first, right?
Yeah.
Argo CD.
So
now, in that, my problem is that sometimes I don't have obvious CRDs. Like Crossplane is going to create CRDs, so Argo CD doesn't know that. But if you give pure CRD, it will be applied first. So that's the advantage, because it knows what's inside.
It will in a Helm chart as well if the Helm charts are in the CRDs directory, right? If the Helm chart would install with Helm install, it will install this way. The benefit in Helm is that anything around day 2 of CRDs, however it's handled in Helm, is how you will handle it as well, versus different in Argo.
Here's the thing I don't understand. A moment ago, you were agreeing with me that we should be running Helm template and storing pure YAML. And now you're defending it in Flux.
Hold on. I agree that it is the better approach. When it comes to installing CRDs in third-party applications, why do I like that? Not because of the benefits here. Despite the negatives of templating before, the fact that I can easily diff what changed in Git makes it worthwhile, meaning you will suffer more on the deployment side, I believe. But it is worth it to have the easy diffing of what in the world changed between version A and version B. That is worthwhile benefit to accept upon yourselves the pain of dealing with Helm template cube apply.
Fair enough. Okay, this is a comment from the before. We had a question about celery. It's a Python library. I know last time I used Python is 10 years ago. I don't know if you, Scott, have anything to do to add here. Are you Python? I know that you're a TypeScript person now. I'm not sure whether you're a Python.
I'm not a Python guy at all, although I have dabbled in it a bit because of AI. But no, I don't really know anything in that area.
Okay, multi-cluster workloads, recommendations. I think we mentioned already a couple of them. I mean, okay, so let's start with my question for you. Would you recommend Flux or Argo CD for multi-cluster? I'm guessing the answer is yes. Because I have a follow-up question if the answer is
deployment, 100% GitOps, right? Flux or Argo, Cap Controller, Rancher Fleet, I don't care what it is, it needs to be GitOps.
So here's a question for you that is not in this question. Do you prefer, it doesn't matter which of the tools we're talking about, do you prefer central Argo CD Flux Cap Controller, or you prefer one in each cluster?
So I actually like a mixture of them. I like one Argo or one Flux that manages multi-Flux, meaning I want the reconciliation of the actual application to happen in one cluster. However, my desired state where things get pushed out from, I like Flux configuring the customization resources in the additional clusters. I don't want each cluster to need to pull down from the GitOps repo. I like having one brain cluster that talks to all of my other clusters, and it applies basically the Flux manifests into that cluster that then Flux locally reconciles.
Okay. But the actual work is done by a
By
Flux
an
in
cluster.
the destination cluster.
Yeah, exactly.
Cool. We're on the same page of that one as well. Cool. Okay.
Now, when it comes to this, you mentioned connectivity and ingress, though, around multi-cluster workloads. I will say that service mesh is great. All service meshes today basically support multi-cluster. Some of them more successfully than others, some of them easier than others. But don't go down service mesh unless you need to, in my mind. It is a huge undertaking to move into service mesh. So if you need it, absolutely use it. If you don't, there's the multi-cluster service export, service imports APIs that are implemented by multiple CNIs. They're implemented in Azure. They're implemented in Antria. There are third-party tools that implement that for you.
Okay.
Cilium has multi-cluster networking. So use your CNI. If you need the capabilities of a service mesh, then do service mesh. If you don't, use the CNI's capabilities of this, because it'll just make your life easier.
Yeah. In other words, don't use service mesh for the if what you need to do can be done with CNI.
Exactly. And for ingress, if you need GSLB type stuff, then that's really going to be provider specific. If you're on premise, the Avi Kubernetes multi-cluster operator, if you have Avi networks, or the F5 has also capabilities for this. Very good. If you're in AWS, use I'm forgetting what they call it. That's their gateway API implementation. But it works also with like Lambda and multiple EKS clusters, and they have their own GSLB capabilities. And there's also GSLB or there's a CNCF project actually that does GSLB for multi-cluster Kubernetes that you can look at.
I will also say that don't go for multi applications in separate clusters that need to talk to each other unless you have to. There needs to be a very strong justification in my head, for me to say it's okay to have applications that need to talk to each other in separate clusters.
But what about having an application running in multiple clusters, the same application running in multiple clusters across different regions that you want to set up a GSLB around? That's what I would view as a valid use case.
But there are many reasons. It's just that sometimes people go crazy and I want to do it because it should be done. For many companies, you don't have to have applications in multiple regions because it doesn't make such a difference. Just spread it across zones and you're fine. It's not that the world is going to end. The benefits are often lower than the pain of doing that. That does not mean that there are no use cases. There are definitely reasons why you should go multi-cluster. Just make sure it's a good one.
The one benefit of doing it with multi-cluster, if you build it with that design, is that then it's much easier to turn your clusters into cattle and not pets, and then just doing the side-by-side upgrades, because you have built yourself your whole mechanisms and your whole methodologies around how something can live across cluster boundaries, because then you spin up the new 132 cluster alongside your 131 cluster, and everything is just going to work because you have this multi-cluster topology, right?
But then we are talking about truly big scale to justify it. We are not talking
100%. Yeah.
Okay, I cannot answer this one for you. Can I ask Scott about his whiskey cooler?
Last I checked, I have 472 whiskey bottles, 0 of them being bourbon because I don't put that in my system. But Scotch whiskey, Taiwanese whiskey, Israeli whiskey, from all over the world. Love single malts. And
Okay. What else? Okay. Right now I have... Okay, there is more from you, Juano. That's the celery question. Right now, I have Vault, TSO, Grafana, Loki, Prometheus, Longhorn, Harbor, Cilium, with GAPE, VI, Cert Manager, Argo, CD, Workflows, Events, and Dagger. What am I missing? Man, you have more than most.
Crossplane.
Crossplane. I didn't want to say it myself because I'm biased, right? Kind of.
Kyverno.
Yeah, Crossplane.
Kyverno's
yeah, Kyverno is missing. Yeah, I mean, now I love Kyverno. I think it's amazing. But now that admission policies are GA, I have a similar explanation like for service meshes. I think you should start with validation policies that are baked into Kubernetes and then switch to Kyverno if you say, you know what, I need more.
So I still recommend Kyverno, and the reason I recommend it is because of policy reports and the better implementations. It's better for traceability and everything like that.
It's 100%. I 100% agree that it's better. It's just that I still like the logic. Don't add stuff until you say,
yeah,
I need more. That can be day one. I don't know.
Right. Yeah. Well, I think this is overall a very good stack that was chosen here. You're probably missing OTel collectors. In this case, some type of telemetry collector.
Look at the next one.
Oh,
start instrumenting the maps. It's on the roadmap.
So I would recommend actually looking at Pixie for auto instrumentation.
Yeah, personally. But then we have a problem that nothing works with Pixie.
Why? You can ingest it into Grafana.
Yeah, into Grafana. But if let's say that you choose to use Argo rollouts or Flagger, will it work with Pixie? No.
Yes.
No, it doesn't.
Pixie auto instruments all of the things that are happening within your cluster. Oh, you mean can they use Pixie as a source?
Exactly.
But who is doing rollouts based off of telemetry data? You're doing it off of metrics, typically.
Yeah, but where are the metrics in Pixie?
Prometheus. This is
okay.
Tempo, I'm saying for instrumenting apps, I'm saying use Pixie.
Okay, only for instrumentation, yeah.
Not for metrics. Metrics use Prometheus.
Yeah, fair enough.
Right? But I say because unless you are the lucky 1 in a million, not all of your apps are going to be instrumented from the code level. You are going to have third-party apps that are not instrumented. And do you really want to build distributed tracing on your own, or do you want to use a tool that gives you 80% for free? And then go and add on to that any instrumentation you want. And that's where I think Pixie does a great job.
Yeah, I mean, and it's very often when you need more, it's not one or the other, kind of like exactly. I tend to get as much as I can without instrumenting, and then when I need to start diving deeper into something, add instrumentation.
Right.
Then you
add
levels.
Some additional things. Exactly.
Okay, this one from before from Elad. What do you think about incorporating Schema-as-code practices into platform engineering to close gaps between DevOps and database management? I have a very short answer, yes. Kind of like, yes, since 20 years ago. Kind of since Flyway and whatever other tools we had back in the day, right? What exactly. I will add is that I'm a Kubernetes freak. I know that not everybody is on the same level of Kubernetes freakiness as me. And if you're into Kubernetes, and I think it's very if your applications are running in Kubernetes, it's very useful to keep schema somehow together with applications, just as many other things. And then we have only 2 choices we know of: Schema Hero, horrible; Atlas, questionable. The license is questionable over there, but much better choice.
And I completely agree. I think Atlas currently is the best solution that exists out there, both if you're going to a commercial offering or the open source version, the free version, let's say, right, which I think is very good. I used to like Schema Hero, but the fact that it doesn't give me any status data and anything telling me when things were actually applied in a normal human readable manner or machine readable manner makes it just not work well with the Kubernetes ecosystem. It's kind of like hey, here's an idea and we're going to throw it into Kubernetes instead of building something in a Kubernetes native way, like Argo CD using config maps and secrets to manage its credentials in a CSV file. I'll just, throw that one out there.
Oh, I thought that. Usually, when I go down that road, my example related to Argo CD would be Lua, but you went now the rabbit hole. Okay. Quick question from Pau. How do you what would you do to have secret transferring or syncing from one Kubernetes cluster to another? And I have 3-letter words: ESO, external secrets operator. Now,
Yep.
I think that until a few years ago, maybe 2 years ago, ESO was missing a huge feature. And I was bugging them until we got it, and that's to push.
Yeah.
Right? Now you can push secrets to your secret manager, store, whatever it is, whatever you're using, and pull it wherever you want. If you want the same secret in 10 clusters, you pull it in 10 clusters.
By the way, that does bring up, that could actually be a solution to our challenge last week, Victor, on sealed secrets versus, what's it called? Mozilla Tops. Because you could actually use ESO to copy over the secrets of sealed secrets in one cluster to the other to copy over the signing keys. And that way you could actually use sealed secrets across multiple clusters, even without an external secret store.
The only way how I can justify usage of SOPs or sealed secrets is for people who don't want to have a secrets manager. If you have a secrets manager, I cannot, use ESO. Please don't bother me with neither SOPs nor sealed secrets.
Exactly. But in those cases where people do want to store it in Git, ESO without a secrets manager, but just ESO from Kubernetes to Kubernetes as a syncer could be a good solution.
Yeah, that's true. That's true. Okay, now let's go to one of the older ones. We did this one. How serious are risks? How serious are risks of using eBPF and everything breaking? There is
much less than you would think, because eBPF code is actually checked, unlike other code, which is not. It is safe in terms of I will not crash your kernel. It is not necessarily safe in terms of what is running on your machine. There could still be very malicious things in an eBPF program. It's just not going to have an endless loop that's going to crash your kernel. So for me, everything breaking, you're relatively safe from an eBPF perspective. From a, security perspective, it's no worse necessarily than a user space application that you give privileges, right? So
exactly. It's safer than you mounting a volume to the proc directory in your container or something like that.
Right.
It's relatively safe. You're more likely to break everything with your own applications than with eBPF. Let's put it that way.
The one thing I would say that is, in my mind, one of the challenges of eBPF is that because it's written in BPF code, right? It's written in much lower level languages. One of the challenges is understanding eBPF code can be quite complex. So what that means is you have to have a little more trust in the supplier of your eBPF-based applications, because you are not going to understand that code like you would a user space code in higher level languages that aren't dealing with that level of detail.
Do you have a preference between Minikube and Kind? I tend to use Kind, but I don't know whether it makes any difference anymore, unless you want to test a specific version of Kubernetes locally.
Correct. I like Kind. The reason I use Kind is because that's what's used upstream. That is what the Kubernetes community has basically blessed, and that's what they have used, and it's just easy. I've never had a need to move away from it. I haven't had the challenges that would force me to move to something else, so I like Kind.
Okay, this one is from before, from Andreas, from last week. Can I run Windows with GPU support in Docker inside of Docker Swarm? I don't use Windows, Scott. Do you use Windows? Do you know? I'm not even getting to Docker Swarm yet.
Yeah, I use Windows.
Okay.
I use containers. I would not know what to answer here, unfortunately. Nor can I comprehend why anyone would. I don't know why Docker Swarm. Maybe Docker Compose I can still understand to some level.
Docker Compose. I don't approve of it, but I understand. Swarm needs to die.
I mean, yes.
Docker said we don't want anything to do with Swarm, so just to make it clear, kind of like,
Exactly.
The people who made it say not for me.
Right.
But so let me rephrase the question. Since you're using Windows, I know that Docker has difficulty running containers. Docker containers in some form or another. On Mac cannot use GPUs yet, but on Windows I believe that that's the case, that you can leverage GPUs, right?
I believe, well, so it really depends on what you mean by on Windows. Because if you're running Docker in WSL,
a VM
for
inside
example,
of Windows,
the answer is 100% yes. If you're running with the Hyper-V isolation, I'm not sure. I don't know if that's exposed. Like, there's multiple ways of two different backend engines that Docker Desktop can use. So it's going to be different also on Windows Server versus Windows Desktop. Windows Desktop in WSL, there should be absolutely no issue with that. In Hyper-V backend, I'm just not sure because I don't run that way. My Windows machine has everything installed inside of WSL, except for applications that run better on Windows. My default terminal is WSL, not PowerShell. But I prefer to have the real thing, meaning Linux, instead of a fake Linux called macOS. Which is why I use because I get an enterprise-grade operating system with real Linux in it.
Okay, I'm going to pass over this one because this would lead us to a dangerous part of half an hour discussing Windows. I can understand Android phones. I cannot understand Windows laptops. And we are going to the next question before you have a chance to answer that one. What type of branching strategy of deployment organization patterns for different environments do you recommend? And I will break this question into two questions, if you allow me, Scott. One is for the repository where the code of your application is, and another one is for the repository that that defines your environments, GitOps, whatever you want to call it, right? And let me start, and then you trash whatever I think. For applications, I believe that we should have a mainline, we should create a branch, work on it, create a pull request, merge to mainline, finished. Unless we have to maintain different versions of something. Any more complicated setup hurts my brain. My brain is not capable of understanding anything more than I create a branch, I create a pull request, merge to a mainline. That's my flow. Mm-hmm. Now, for GitOps, I don't believe in branches. I think the branches are silly. I really dislike when I see somebody say having a repository and then mainline would be production and then Q&A would be branch, because I strongly believe that branches should be mergeable to the mainline, not something that has a completely separate life. I prefer having different environments, either different directories or different repositories, and that's it. Right? That's my picture of it. Trash it.
So I am not going to trash it. This is an area that I believe that we as an industry have utterly failed at. I agree with you completely on the code side. Right? The code repos, we're going to have no disagreement there. GitOps, I think, is a utter horrible idea. What do I mean by that? Git is not the right tool for what we are doing in GitOps. It is the best thing that we have today, and there is nothing better than that, so everyone should be doing GitOps. However, the main challenge is that when you move to folders, which I believe is the lesser of all evils today, But diffing between versions and how do I make sure that I make the changes that I made in QA into production and that there's no promotion, actually, it's me just CPing a file in CI from one directory to the other. That isn't good. I think that this is where I hope that Pickle was going to move in the right direction, and I think it moved in the wrong direction as a language. But the separation of schema versus config is something that GitOps doesn't know how to handle, because I want to promote my schema but not values. If there was that ability, then I would say branching. But because that doesn't exist, unless you're using external config managers like HashiCorp Console or something of that sort, then you have to use the folder structure, I believe. But if you are using external config tools like Spring Cloud Config or HashiCorp Console to actually pull in the values at runtime, then a branching strategy does make sense, because you can actually just merge from QA to this because you're just upgrading the schema between versions and actual values are stored externally.
Yeah, I mean, I guess that. Okay. So, what my answer before was referring to values. You confused me for a second when you said CP. There is no CPing because QA and production are never going to be 100% the same.
Correct, but what happens when you added 4 new Helm values?
Yeah,
in the new Helm chart, you have 4 new values.
Okay, so in my case, there is. So let's say that I have 3 environments, right? I would have 3 Argo CD applications pointing to doing 2 things: pointing to a specific version of a Helm chart and overwriting specific values. When I release a new Helm chart, I might update one of those 3 apps, or 2 or 3. Right? So kind of
right.
In my case, I'm talking about Helm now. Argo CD definition is the equivalent of Helm values, right? That's where I overwrite the values.
Correct. What I'm saying is the challenge there is that you have no promotion of schema changes over time, meaning when
when you want the new values, yes.
Right? Because
right.
what you actually want, the reason you want a branching strategy is because you do want to actually, like in theory, you want to be able to promote schema between versions of your values. What you don't want to do is promote the values from dev to QA, from QA to pre-prod, and pre-prod to prod. But you do want to migrate the schema across that. And that's why Git is just not the right tool for this, but it's what we all had. It was the de facto standard, so there was nothing better. But in the ideal world, we would have a, something else like Git that actually handled that for us, or some config language that did that, or use an external config system. That's only at huge, large scales, though. If not, use folders and, hope not to break yourself.
Yeah. The only thing I would add, and I don't know what's your feeling about it, is that when I change the schema, or even without changing schema, let's say Helm, right? I believe that the defaults should be production. And then we struggle to modify non-production to be something else.
I completely agree that the defaults should be production. That's just
because
a bit challenging.
That doesn't solve the problem you mentioned
until you reach pre-prod and ran your, bench load testing to understand what it should be, right? So, but yes. Okay,
next one. This is from before, going back and forth. What about Firecracker versus self-hosted GitHub Runner? I self-hosted GitHub Runner only once. So either you know something about it or we skip it, Scott.
So self-hosted GitHub runners, awesome. Use them all the time. Great idea because they are 100% free as long as you have the compute. So I run them in Kubernetes and then they run within my lab environments where I have all my internal networks. They have access to everything and you pay 0 to GitHub for that, even in private repositories. So it is great for long running tasks and is almost no maintenance whatsoever. So self-hosted GitHub runners in Kubernetes, definitely the way to go in my mind.
Okay. From Adam, this is live. What do you suggest to use in a small company for hosting own apps for development and testing purposes? We have tried Kubernetes, but we find it too much, and I agree. Is Docker Swarm the way to go here? And I utterly disagree. No. 100% no. It's dead. Docker Swarm is dead. Please don't. I mean, just as you shouldn't use WebSphere unless you have it for 20 years. So here's my take. Assuming that you can go cloud, public cloud, Azure Container Apps or Google Cloud Run. And unfortunately, I'm not sure that there is something equivalent in AWS.
Yeah. But definitely Google Cloud Run, Azure Container Apps, Azure Spring Apps, whatever it is from
Fly.io
into what you're doing. Who cares? Use the managed services. Use Heroku as far as I'm concerned, or anything of that sort. That is a managed service that you just give it to it and it runs your app. That's simple and easy. Awesome. The best one of those in my mind, personally, even though it's not my favorite of the clouds, is Google Cloud Run. And the reason is because it has a Knative API to it. So what that means that it's very easy to get started that way. And when you need to move to Kubernetes because you outgrow what the SaaS offerings are giving you, or you just can't pay that money once you reach a certain scale, then it's easy to move that into Kubernetes.
And even without the compatibility, which is a huge plus, Google Cloud Run is awesome all over.
Exactly. If you are on premise, though, then that is where it gets challenging. I think that the answer in those cases is yes, Kubernetes, but Kubernetes from a vendor that comes in stupid, simple, managed, whatever, and Knative or something on top of it, and you never actually deal with Kubernetes itself. Basically, give yourself a self-hosted Google Cloud Run, which is literally Kubernetes cluster from a vendor or some packaged solution that does lifecycle management, all of that, and one application installed on it, which is Knative. And just make your life easy. Don't start dealing with Kubernetes apps.
Yeah, but when you say easy, that's only probably for both of us. The answer would be yes, but it's easy only if you're very, very comfortable with Kubernetes. Somebody in that organization. Because Knative is amazing for the end user perspective, but when things go wrong, you still need to figure out what's happening on Istio level, what's happening on this level. There are 57 different things that can go wrong.
There's no question about it. No question. If you want something easier, use OpenFaaS, but that's more for function as a service. But if that's what you need, it's great. But Knative is like the standard, I would say. The challenge is when you are on premise, and this is what I always say, when you're on prem, you have to build the services that the clouds give you. If you are in the clouds, utilize that and make your life easier if you're a small company. If you are on premise, you have to build that. And it is better for a small company to hire two senior engineers that know Kubernetes that can run that stack for you and deploy Knative on it than to try and train the company to work Kubernetes natively.
So this is the thing. I believe that there are two options, kind of like, can we have some very low effort solution? That would be Google Cloud Run, Azure Container Apps. And I don't believe, and I might be wrong because you work more with on-prem, I don't think that there is no effort on on-prem. And then if there's
no effort for the consumer, but in that case, it's what I tell every IT team, you are AWS. Do you think AWS had an easy time building AWS? No, but your job is to be AWS. That means that you need to have the expertise. The rest of the company doesn't.
The reason why I'm saying that is that if on-prem there is inevitable investment of some sorts, then invest for some sort of a standard, and that's Kubernetes. No matter the complexity, kind of like there is no other standard. And it's okay not to use a standard in Azure because you're getting it for no effort, kind of, right? I mean, low effort, right?
Yeah.
don't use anything but Kubernetes on-prem. That's my message. And then go Knative on top of it. Otherwise, you're just investing in something that is not going to last, or we don't know.
Exactly. And don't use Istio with Knative if you're self-hosting and you just need simple. Use Contour or Courier. Just use an ingress controller. Make it as simple as possible. Don't make your situation complex. Please make it simple. Make it easy.
I feel that this is something we can talk for hours now, granular security. So there is no one answer. The only thing I will say, and I will let you then say your piece, is that this, and what I'm going to say applies to many other areas, not only security, right? I think we should stop trying to secure things outside of the destination, right? Hey, I need to ensure that my pipelines are running this or that. I need to ensure that whomever is using CLI is executing this before they execute that, right? With Kubernetes, we have now a mechanism to ensure that when things come in, they're somehow validated. Can you do this? Are you the right person? Is this the right manifest? We're talking about Arbeck, we're talking about Caverno, we're talking about whatever else. There's a bunch of tools, but kind of focusing on the right side of the API simplifies so many things. Because I was in the past often in situations where people say, hey, we're going to do this thing from, let's say, from pipelines. And then as a result of that, we cannot allow anybody to do anything outside pipelines because it's not secure anymore.
Yeah. So security is a multifaceted element, right? We need runtime security. We need admission controllers. We need to also shift left security by adding IDE plugins that are validating things before it get to CI, right? We need to, yes, you need to run vulnerability scans in CI, and I believe that CI should be signing artifacts, and then that should be validated when you are deploying. That's one of the validation policies should do. I think that the biggest mistake people make is that they try to do these different things. Runtime security is very different than admission security, right? What gets in is very different than validating that what is supposed to be running is actually running, which is very different than the scanning of CVEs, which is very different than, hey, you're writing a bad YAML file, right? These are all different things, and they belong in their own places and their own contexts. And there are better tools for each of them with different user experiences, and they should not be all shoved together into one solution that tries to do everything.
Oh, yeah.
I believe in best of breed for each place.
True. But what that was, and I completely agree with you, but I like to distinguish, and you're probably going to disagree with, how there are two things. How do I make sure that only things, as much as we know, happen in a secure way? And that's kind of API level and right. Kind of that's the only way I can ensure things, right? And what is happening on the left of an API is important, but they're more like helping users somehow. Kind of like, hey, I can help you validate that this value is correct sooner rather than later. But that's not a reliable validation. I'm doing a real one over there, right?
Exactly.
And earlier I'm helping you
feedback early in the loop.
Exactly.
I'm giving you feedback early in the loop of validation. A IDE checking the validation of a whatever using, kube linters and whatever, that is not at any level a replacement of Kyverno validating it at the entrance to my project. The two, I completely agree with you, and I think people have messed that up. One thing I will say on granular security also, though, people are going too granular in many cases as well. There is cognitive overload that happens based off of what levels of security and what you're actually running and what your risk levels are. Not everyone needs end-to-end MTLS with this and this and this and this and these cryptographic keys. No. Yes, obviously we all want to be there, but we also have to be sane. This is where I think that what is it, Cubescape or Cube Armor? I'm forgetting which one that does
Cube
the auto
Armor.
vector generation.
Okay.
I think that's Cubescape that does that, the automatic vector generation. And that's awesome, right? Because Vex is the first move, I think, in the right direction in the security world for a very long time, where Vex has basically come and said, okay, you have 1 million CVEs in your application, right? Now,
Exactly.
we can come and say, I'm going to block on every critical vulnerability. However, what if I'm using Kotlin as a language and I'm deploying Kotlin on an x86 or whatever architecture in Kubernetes on an Ubuntu-based image? Well, there are multiple critical CVEs in Kotlin right now that affect running on ARM64 on Android operating system. However, when you run Trivy scanner or any scanner for that, right? It could be any, I don't mean to pick on Trivy here. It could be Gripe, it could be Trivy, it could be Prisma, it could be anyone. In the end, you run against it, it says, hey, there is a critical vulnerability. Yeah, but it's not exploitable in my environment, so I don't care. And therefore, we need the vulnerability exploitation exchange, whatever VEX stands for, says, okay, what am I susceptible to, right? And that's where we need to move. Stop with these detailed things. Let's look, where am I actually affected, please?
Yeah, I mean, kind of what is really insecure in my context. And I think that's what everybody forgets, my context.
Correct.
Right? My context is my cluster or my application or my code or whatever that is. And
what's exposed out to the internet way worse than what's not exposed out to the internet. And
because, I feel that every single company I've worked with, they always have the number of vulnerabilities that will never be fixed. Kind of like they all waste time going through the lists of things that they know that they have no capacity to work on, right? And even the other day, actually, last week, or 2 weeks ago, without naming names, one of the people from a project in security space contacted me. Can you take a look at this? And they're giving me the demo and say, okay, this is against my production cluster. I said, great, I love that. You're showing me the real thing. Excellent. And we have, you see, our tool now detected, I don't know, hundreds or thousands of vulnerabilities. And I cannot, man, if you cannot fix your own vulnerabilities, there is something wrong. How do you expect anybody else? But there's so much of them. And my response was, I understand. Nobody can fix this. But don't expect others to fix it either. Kind of like, we need to somehow, and I love that you mentioned that, Scott, we need to move into the world of tools telling me what is the real danger I'm having there. I'm going to fix it. But give me the real stuff.
Give me the real things. And that doesn't mean you shouldn't upgrade your Kotlin version to also get rid of that vulnerability. But that means that is the lowest priority beyond the Golang vulnerability that is exposed in a web app of yours that right now is open to the public internet. Even though it's a high and not critical, that is way more critical than the critical vulnerability that is not exploitable at this moment.
Exactly.
So it's about finding the right tools that can do this.
Okay, let's do 2 more questions. Quick run. This probably is for me. You don't use the accuracy that much. Application sets or applications. Most of the time, I prefer applications. There is something rubbing me wrong, and I cannot explain even what about application sets. The place where application sets are useful is what me and Scott discussed earlier when we were talking about the GitOps and branching and stuff like that. Is that you have one place where all the values are located. And then when the schema changes, it's kind of easier not to miss it than having multiple files. But outside of that, I prefer applications. If you have something to add, probably not. Yes, no? Okay, go for it.
Nothing to add. Go CD.
Okay, the last one. Crossplay functions can be a pain. With host port requirement, especially with Kubernetes platform like EKS, which does not expose a service in a cluster to talk to control plane. I'm not sure that I understand this. Do you understand this?
No.
Because
Trying
crossplay
to
functions do not expose
understand.
ports unless you're really going funky and saying, I want crossplane to talk to functions that are outside of my cluster.
Yeah, I'm trying to think what this could be. The only thing, well, they do have a cluster IP, but that shouldn't matter. Does it?
Yeah.
Do the functions need to talk with the API? Does the API server need to talk to them or something? And therefore, on EKS, where you don't have the connection to the control plane, it needs to be host port. I didn't think so. I
don't think so. And I run. I mean, if you want to ping me SR, we can talk about it because I use it in EKS all the time and never. No, not the problem.
Yeah.
Okay, let's do
one more.
more.
Pings around functions, right? But I have never seen this painter on functions.
Okay. Let's do one more. In an EKS environment, would you completely ditch VPC CNI for Cilium, and on a similar note, AWS LB controller or third-party ingress controller? And I'm very split on this one. Because I'm going to answer the question not directly related to AWS, and then you turn in. On one hand, if it's not a big investment, if it doesn't make big a difference, I prefer going with whatever your provider offers you. Kind of like, if it's no friction, whatever they think it's fine, unless we start investing and then really doing for it. On the other hand, I don't understand why AWS is not adopting Cilium as the default, but AWS does that all the time. They're usually the last provider to go for the unofficial standard, right?
Listen, you could have said the same thing about why didn't any of them go with Calico when it was the de facto standard before Cilium came around, right? So I'm not sure necessarily that I think that Cilium is the best. I think it is becoming relatively one of the major standards in the Kubernetes space. I think a lot of that is hype related, but it has definitely succeeded. In AWS, I would say always use VPC CNI unless it doesn't suffice your needs, and then go with Cilium. When it comes to the load balancer or the ingress controller, that's where I have a lot of internal debates, though, because it really splits into two groups. If you are only EKS and money is not an issue, use the AWS LB controller. If money is an issue, then you use third-party ingress controller because you don't want to be spinning up an ALB for every application, and you would rather have one load balancer and do all of the routing in cluster. If you are multi-cloud in any sense of the word, that could be on-prem and EKS, that could be EKS and GKE, that could be EKS and AKS, whatever it is, ingress controllers are something that should be, at this point, if you are using the ingress API, then it really matters that you don't use the AWS LB controller and use a third-party ingress controller that's the same everywhere. If you're using gateway API, then I would say go back to using AWS LB controller, use Google's implementation of gateway API because we have now a generic API. But ingress, every ingress controller, Nginx has 250 annotations. This one has 7,000 annotations. This one has 20 annotations. Everything is so different that you want to standardize.
Yeah.
I would say.
I mean, the way I see it, I see those as a very different levels of effort or investment. For me to change the CNI that comes out of the box with my provider, EKS, right, is an important decision that, as you said before, yeah, let's go with Cilium, but there needs to be a reason for that, not just because it's Cilium, right? So I would go for VPC CNI, right? But on the other hand, ingress controller, that's just single Helm apply. Kind of, I see no reason not to use whichever controller you like. Traffic, Nginx, doesn't matter, whichever it is. Kind of, I see no good reason why to use AWS for ingress.
The reason is support. The reason is support, right? It's what they validate against. It's what they run. It's what you can call 1-800-AWS, and they will give you support on the AWS
Okay,
ALD
fair
controller,
enough.
right? So there is a benefit in that. And it integrates better into AWS's ecosystem, right? So you will get CloudWatch and you will get all of these logs and the deep integrations that ALD has directly in there. It integrates with ACM, right? With the AWS Certificate Manager, right? So if you're an EWS shop, then there is a value in utilizing the ecosystem, right? However, that also means you lock yourself in more and more into that ecosystem. So it's like it's a beautiful garden that you're building walls around and making it very difficult to leave when you use the proprietary technologies of these different vendors. There's a reason they exist. I typically am less a fan of proprietary. However, I see the value in the ingress controller if money is not of concern. If money is of concern, then you have to use a third-party ingress controller. My favorite in this area is Contour, but it could be Traefik, it could be Kong, it could be Nginx, it could be whatever you want. Doesn't really matter. Please just choose one that supports Gateway API. That's all I would say.
I was about to say that if you made the choice years ago, yeah, it's fine, whatever you chose. But if the question, I assume that question is, what should I be choosing today? Please don't choose anything but Gateway API.
Well, so I will say, I did not say choose Gateway API. Choose an ingress controller that supports Gateway API. Don't necessarily implement Gateway API right now. It may not be what you need at this moment. If you're a small team managing things, maybe you are with ingress right now because you know that. And that's fine. But don't choose a technology you're going to have to tear and replace because Nginx ingress controller does not support Gateway API. So don't choose it. Contour does.
That falls into I think that we are using different words for the same thing, right? Kind of like if you already know this ingress, that means that you're already using it and so on and so forth. That's fine. Stick with it. I was referring more like if you didn't make a choice, I assume that you're not proficient. Huh?
Right. A new person to Kubernetes who doesn't yet have experience with Kubernetes. Yeah.
Yeah. Especially since I don't know what's the situation in AWS, but in Google, for example, that's a choice now when you create a cluster. Do you want Gateway API? Just there.
AWS it is as well. They have their tool that does Gateway API that's implemented. That's very, very powerful and easy to use. Azure have it as well, right? So they all support it. VMware supported in their Kubernetes. I believe I don't know if OpenShift does because they still have routes, and are they really going to have 3 APIs to manage the exact same thing? I just don't know because they have ingresses and they have OpenShift routes. I don't know about them on Gateway API, but yeah. Anyways.
Okay, folks, that's it. We are over the time. I'm going to collect the questions we haven't answered from today's session. I'm going to keep the questions we haven't answered from the last session. And eventually we will get to so many questions that we will never answer them, but we'll try. So see you next week. Thank you all. Cheers.